Today I'm going to do a quick setup of the AS30 array sensor. Once you're already in Sopus Engineering Tool and you've got it connected, we'll go ahead and open it up. So today what we're detecting is the bead width and position on this piece of cardboard. So if you're just starting to set up the sensor, first we'll go to sensor setup, and we'll use the alignment tool provided with the sensor. If you happen to lose that tool, you can print it off of the literature section of SICK website when you go to this sensor. So we'll just alignment teach in. Once the teach in is successful, then we'll bring our workpiece back and go to next. We will be detecting the width. We will be on the connector side. And once we've got our workpiece under there, I'll go ahead and go to coarse. And we set the edges are very defined. And we'll go to next. On pin 2 will be the 420 milliamp signal that is sent out depending on if we choose width or center position. And we'll go to finish. All these settings are mainly set up when you go through the quick setup. So we will be detecting the width measurement. We'll be detecting from bottom to top. I will do the edge teach in. And here's where we can adjust our 420 milliamp signal to kind of close in that window and also make a more defined scaling. What we're worried about here is trying to set up the when we want our discrete outputs or discrete input for the PLC to be triggered when we see a failure, being that its the size of the bead width is too large or too small, or the location of it. So what we need to do, look here, we'll turn both of these on, which I already had on. Open up our process data so we can actually see the width and where the edges are. And from this area to right around here is what I want to call good. So what we'll do is look at these numbers and see when they start to drop off. So from here to about here is when I want to say it's good. And anything outside of that, we want to say is bad. So let's go ahead and open those windows up. So I'm looking at edge 1. And at this point, I'm down to about 8. So let's say 8 window mode. We want to look at edge 1. I want a minimum of 8. And a maximum of about 15. Let's go ahead and open that up and give it 17 just to see what that looks like, and we'll watch this data to begin with just to make sure we're not falling out until we're supposed to. So I see a failure there. My bead is starting to get too close to the edge, and I see another failure there as it's starting to change positions. So that seems to be set up fairly well. Now the next thing we want to do is we will also put in a window for the center or the width, if we're looking at width, and kind of look at those numbers as well, which is displayed up here. So we know from a good point over here, just over 2 millimeters seems to be doing well. And it gets irregular around there. So we're jumping all over the place. So we'll go ahead and set that in between 2 and 4 millimeters. Now in this area, we should be looking at both of these signals to make sure they're both staying high at the same time. And when we get into the failure zone, we should see them drop. So once we've got that set up, we want to use both of these to go with the the discrete output. So I've already got this set up as an out. So if you look right now, both of our signals are high. So what we did is kind of put an AND gate in here so that both of them have to work together. If either one of those drop out, then now our signal dies. So that alerts the PLC that something is abnormal. Either we've got abnormal amount of caulk or bead width, or we've got out of location. Thank you.